Hello, welcome to my YouTube channel and my video today. Thank you for checking it out. Today's video is going to be about my motherboard project, one of the biggest updates I've had in a while. There's still one more update coming, so this is not in its final form necessarily. Um, so anyway, my channel's been mostly about this project and a few other related items. So anyway, I'll get right to the board. So what I have is it's PC compatible 8088 motherboard. And this board is modeled after the IBM PC 5150. It's not exact, so if you're looking for an exact replica, it's not quite there, but it's very much modeled after that. So anyway, let me just start with the main board here. The one thing about this project is I wanted it to be made with modern parts that are available on the market. So you're going to see a few parts here that would not have been native to an original PC. So you can see you got a basic motherboard, enhanced backplane, if you want to call it that. It's not really a backplane at all anymore. It's definitely more on the motherboard side. Got 7 card slots, and this board is designed to fit in an ATX case with 7 slots, of course. We got an ATX power supply. You can plug in a 24 pin or a 20 pin power connector. It doesn't care. There's a little line down there that'll say 20 over or 24 over 20 to kind of indicate which end you plug the 20 in, which I don't think you can plug it in the other way. That some of the holes are round and some of them are square or roundish. It's got a PS2 keyboard connector. No PS2 mouse. Main reason there is the PS2 mouse would require interrupt 12, I think. Anyway, it's above, it's IRQ12, that is, sorry, not, or 1.2. It's above the threshold of the interrupts that are available. So you got to use a serial mouse with it. Everything on here is labeled. So starting here, you've got your DMA controller. This one here is an 8237. The 8257 doesn't work. I don't know if there's just some difference I need to wire, but you can't, they're not interchangeable. But underneath it, it'll say port 00 to indicate which port that is mapped to, which is the same as the APC. We've got an upper address buffer that's related to the DMA controller. An LS04 here for doing some inverting on some pins that need to be inverted. And then I've got the LS670 here, and it shows that it's at port 80, and which is the same as the PC, and that's the indexing register. So that's the big addition right here, is adding the DMA controller to the board. Anyway, so we'll keep going. So from here on, it's been what my boards have been. You've got your 8284 clock, and this is not for the processor. This is for the ISA bus, as well as providing the correct frequency for the speaker and the keyboard controller. So next to it, you have a 74LS74 clock divider. Right here, you've got some LS138s. They divide, or they decode the addresses for your ports. And they're fully decoded, all down to leaving the last 4 bits. So the upper 12 bits are decoded. Basically, if you need to decode the lower bits, you would do that on the additional item. And I'll show you here in a second. Some LS139s here, which are more decoding and logic for the speaker. And then power button, just latch in and out, and a reset button on the board, and a power pin header that can go to an external switch. It's a throw switch, not a push button, for your power. So up here, we've got your keyboard controller which is it says port 60 on it, 60, not 60. It's all a hex, and port 661 here. So it's a read-write port, and it's used to turn on and off the keyboard controller, but I don't think I wired that pin up. But it's used more to turn the speaker on and off, and the channel check on and off is what mine really does the most. And on my website, I'll probably put the pin out on there someday, what's actually mapped. A lot of the pins on here aren't mapped to anything. LS07 here, that's used with the keyboard controller. So that's the main board, other than you do have a pin header here, a female pin header, and it's mapped to port E0, and that would be for the hard drive. So on my board, I chose to use a USB hard drive because of the availability, and you can take this and unplug it, plug it into your regular PC, copy files to it, plug it back in. It's not hot swappable the way it's coded, so you have to reboot, but it's easy to get files on there, on and off, as you need. So originally, I was using a factory-made USB controller, the CH376, and the ones I started buying recently, and I got a couple bags of them, they've changed the pin out, so they're not pin compatible to my controller. So I made my own. It's just a copy of theirs basically, but with through-hole soldered items other than the USB controller itself, which is surface mounted. You know, I didn't have tweezers and all that to surface mount the capacitors that are, but it's a decent copy. It works. There's been suggestions that I put the USB here so you can plug into the back, which would be great, but in all reality, what I figure you do is you put this on an ISA card, plug it into one of the slots, put dual, maybe quad USB on there, you know, for multiple drives. I think that'd be a better option. Also, where this is surface mounted, I'm wary of surface mounting it to the board because I'd say 1 out of 5 don't work on me. Either I've done a bad job soldering or they're bad chips. And so I don't want to risk destroying a complete board because you can't really test it till you build it as far as whether the chip works. I have thought about maybe putting the socket on here and then making a module that just plugs right in so that I avoid destroying boards with the surface mount. But anyway, that's enough of that. Processor card. Now, there's a lot of reasons why I've got the processor on its own card. For one, this is a 2-layer board. By the time you throw all this down here, the traces get pretty thick. It's not impossible. It's very plausible to do, but it gets pretty thick. And actually, by having it on its edge, it gives you another dimension to work with. That's one big advantage. The other advantage is you can plug in a different processor card, like this V40 here, that has the memory built in. So V40, 8088, and also you can use V20s as well. And something else you can do, so this has its own crystal. You could put, this is one that runs at 8, but you could make one that runs at 4.77 to match the original PC. That way you're not unsoldering your crystal to change that out. I mean, there's some advantages, disadvantages to it, but anyway, basic processor card. You got everything on the card is native to this processor, and anything that's kind of universal goes on the motherboard between the two. So you have your latches here and here, and then here and here's your latches, data transceivers here, interrupt controller, and then a programmable interval timer here, your clock, and then your I/O read-write, memory read-write decodings here. This is an LS, I think it's a 275. Let's see if I can read that. Yeah, 257. I actually found that in a 8085 manual for decoding the IOs, and it's really handy because when it's put a hold on the chip, the hold acknowledge will go to the enable lines on these chips here. This also has an enable line, so it causes them to float, which is it's a great chip to use for decoding your IOs. Anyway, the memory comes on its own card as well. So the main reason on this is to be able to upgrade or downgrade whatever you need for your system. And then I did make a board where it's built in. This is not my typical V40 card. I just don't have one on hand at the moment. I think I sold them all off. But yeah, so the memory is on its own card so that it can be upgraded. And then once again, if you were to put all of this built into the motherboard, it's not impossible, but it gets pretty thick on the traces. Also, if I want to upgrade just a portion of it, I don't have to rebuild the whole system or redesign the whole system. I just redesign that part. So these are all labeled. You have address 0 for your bottom 512K. It's a AS60408. Next to it, I've got the 1008, which is another 128 kilobytes. So you got a total 64 kilobytes here. And then next to it, you have your ROM at the top, which this is the 64K board. And this one's at address F0000. And you can put in anything that's pin compatible with the W29C020. You can go like the 256, you can go to 128 or 64, as long as they're all pin compatible. But it only reads the bottom 64 off the chip. But whatever you got on hand, you can plug in there as long as it's pin compatible. The upper address lines are just tied to 0. Next to it is a slot that's mapped to port or address E0000. And on this particular one, I have a disk on chip plugged in. But you could plug in another ROM if you want 128 kilobytes of ROM. So check out my disk on chip video on that. So that's kind of the motherboard as a whole. And so what I build, what you see here, the only thing you need to add to this to get it up and running would be the PS2 keyboard and a video card. And this one here is an Oak-Tech card. I would recommend the TVGA cards, the 9000 A, B, I think. I've got some Bs. They work fine. They seem to work better than the Oak-Tech card. That's what I use on my regular PC is the TVGA. You can use a CGA, but they're not quite as clean on as a regular PC. There are some shortcomings when it comes to CGA in this system, but they will get up and running. They're just not, and maybe it's just that I'm not accustomed to how blurry CGA really was, and that could be it. So that's how I usually send these out is with what you see here. I mean, of course, not with the disk on chip. That's an additional item, but anyway, let me show you this in the case. I actually had to pull my. I only have one memory card, right? Well, I only have one ROM card, so I had to pull off the memory off my case here. So it's going to get a little shaky here. So this is the PC in a case. So as you can see, I'm going to pull out here. It's a 7-slot case, but it doesn't fill the whole area. It doesn't fill the whole void in here. But what we're really after is all the card slots. So you can see just a regular standard ATX power supply. And on this one, I have a floppy drive. I have a multi-IO floppy drive. Comes out the back here. So you can see I have parallel port, serial port, game port. I don't use that. I've got a network card in there and my VGAs down there. You can see there'd probably be enough room to put a USB here. Maybe slide this over a little bit one way or the other and put the USB on there. So anyway, I'm going to break the video here and I'm going to get set up and I'm going to show a little demo of it booting up, run and check it and that kind of stuff. So catch you in a second. All right, got it set up here, just booting up. So this BIOS was written not by me. There's been a lot of great guys that have worked on BIOSes for this. I do have my original BIOS available for download. It is pretty awful, but it will boot up with a CGA card, barely. So anyway, some other guys have definitely taken some time to work on some great BIOSes for this system. So we got to boot up. This has got the disk on chip installed, and I've got a mouse installed. So let's just run edit real quick, show that the mouse driver is working. Using, I think it's MS-DOS mouse driver version 5. I do have another video talking about using like Qt mouse, I think it is. So it's all plausible. So you can see the mouse works. I'm not going to do a network demonstration today. I don't even have it set up. I don't have a decent mouse pad. There we go, that a little better. It's just a regular ball mouse. Let's run check it. So one of the big changes that I'm going to make on the board, not big change. So the DMA controller is what controls the refresh cycles. Now refresh is for DRAM, and this doesn't have DRAM. So I haven't felt that having a refresh is necessary. And when I have had it working, you just have a slower system because you're waiting for the refreshes all the time. Like it's noticeably slower. But I'm wondering if maybe there's a few ISA cards that may need it. I don't think there was, but there may be. So what I'm going to do on the next version of the board is I'm going to give a jumper or a switch that allows you to turn the refresh, because it's hardwired right now, not even there. So let's just test the system board. So you're going to see come down, of course, 32-bit stuff, 386, 286 stuff isn't going to happen. DMA controllers is testing, and it's always going to say failed on this version because of that channel 0, which controls the refresh. But what you're going to see here is you're going to see the DMA controller failed channel 0. If you were to remove the DMA controller completely, it'd say channel 1, 2, and 3 as well. So the thing about the DMA controller is you need it for a floppy drive and some Sound Blaster cards, I guess. So if you're not running a floppy drive, you don't need it. But it's now on the board, so it's kind of built in now, you know. So this check it. You can use it to check a few things. Let's benchmark the main system here. It's going to determine it's an 8088 running at 8 megahertz. The V20 does run faster, noticeably faster. The V40 is not quite as fast. It's got some built-in wait cycles. At least with the BIOS I'm using, they're fully maxed out. But there has been somebody that took the V40 and removed all the wait cycles, so it's just as fast as the V20. But you can see, compared to a PCI XT, it's 1.78 times faster, and on the mass speed, it's 1.82 times faster. What else can we look at really quick? The hard disk, I don't think it can't figure out the hard disk. Actually, maybe it is this time. Might have crashed it. Oh, it's doing something. There you go. Let's see. Skip entire test. So, yeah, it has trouble with the hard disk because it's not a standard one. I'll get out of here, but let's see what else we can check. So I've got some basic games on here. Let's run Digger. Now this is like an original version, so it's not it'll run remastered as well, but so this is Digger running. Anyway, I'm going to boot from the floppy disk. Now, something about the floppy disk is, even though it's a 3.5-inch disk, it needs to be formatted at 720 Okay, the 1.44 disks don't work. I'm sure with some code and some work, it could work, but it's like the system, the BIOS has never been written for, or it's not detecting a 1.44 capability. So I had to actually buy some disks off the internet that were 720K formatable, and I think I can't remember. I made a whole video on it, so I checked that out. But just showing that it does boot up, which if you're familiar with my other versions, I had to have an add-on DMA card, where this one doesn't. You can see that it is booting native without the add-on card. So there it is at the A drive. What's on here? A few things. Let's see, C colon. Now, I'm going to reboot. So I didn't load the disk on chip because it's not in auto exec or the config.sys on that floppy disk. So the disk on chip didn't load. But I did make a whole video on that recently. So if you want to see how you can run it with just a disk on chip and not a USB, it is possible. So anyway, that's kind of a quick demo. Showed a few things, but if you watched it this far anyway, feel free to hit the like and subscribe button. It helps out with YouTube views. I'll catch you on my next video. Thank you.